everyone. Well, I hope you're doing well. This is our next to last lecture for the class. I'm going to post one more today, and then that will cap the material that will be eligible for the final. Almost done with the semester. So when we think about where our energy comes from that we use in the world, these are all the different sources that we use it for. All the different sources. So solar energy, fossil fuel combustion, wind power, hydroelectric power, geothermal, tidal, and nuclear energy. And so if we step back and think for just a little bit, where does this energy come from? Well, I'm sure y'all could tell me that it comes from the sun, right? So solar energy, of course, we know comes from the sun. Fossil fuels come from the sun, right? In the sense that this is energy that was captured by plants hundreds of millions of years ago, then buried underground. Wind power comes from the sun because it's a warming of air masses that causes those air masses to move around on our planet, and their energy can be captured. Then hydroelectric power as well, right? The water cycle also is driven by the sun. So it's interesting to think that so much of the energy we use is derived from the sun, either directly or indirectly. So the carbon cycle comes into play here, right? So when we talk about fossil fuels initially, right, we discussed back when we talked about biogeochemical cycles, this idea that organic matter that is that does not decompose, given enough pressure and time, can form fossil fuels, right? So coal, oil, and natural gas come about in this way. So it's a net movement of carbon out of the atmosphere, captured by plants through photosynthesis, and then stored underground until we take them out to use them now. So 100 to 500 million years ago, we had these swamps, and all the areas that have rich deposits of coal now are places that were swamps hundreds of millions of years ago. So what happened was that swamp plant material died, but decayed very little due to a lack of oxygen. So it was covered by many layers of sediment, and then, given enough heat, pressure, and time, turned into coal. So if you look around the planet at coal reserves, North America has quite a bit. North America has quite a bit. There's more in Asia, but North America does have a fair amount of coal, which is why it was really the fuel of choice initially during the Industrial Revolution. But we need to step back a little bit and think big picture, right? And think about how sustainable coal really is. So we can ask ourselves, how long would it take to use up global coal reserves at the current rate of consumption? The answer is only a few hundred more years. Now that might seem like a long time, but remember, our country has been in place for 250 years. So if we imagine how much, that much time again, we'd be completely out of coal. And keep in mind, right, it's not that we're going to wake up one day and it's gone. It's just going to become more and more scarce. And as it becomes more and more scarce, what happens? It gets more and more expensive, right? So the sooner we can switch away from coal, the better. Not just for the climate, but for economic reasons as well. So how do we get at coal? Surface mining or strip mining is one way. What this looks like is removal of rock that is sitting above these coal deposits. So this is what's called the overburden, all the rock and soil that you have to remove to expose these shallow coal deposits. And the way that we do this a lot in the Appalachians is through the process of mountaintop removal. So as you can see in the image, you literally have to blast away the mountaintop to get down to where the coal is. And all of that rock, which you don't need up above, is dumped down into the valleys, you can see on the right. So thousands of miles of streams have been buried from the top of these mountains that were blowing away to get at the coal down below. So what does this do to the environment? Well, a few things. First of all, erosion, right? Because we don't have the plant matter there anymore to hold our soil together, so we lose the soil. Acid mine drainage is a problem. So when the minerals under the soil are exposed to air, they oxidize. And this causes creation of acid, particularly sulfuric acid. And so we see this, when you see kind of this reddish water, that's generally because there's a lot of iron dissolved in it, oxidized iron, and acidification is what leads to that. And then, as I mentioned already, there's massive burial of headwater streams as well because of this. This is runoff off of a surface mountaintop removal site. But what we don't know as much about, maybe, what people don't realize, is that there is a huge human health impact to this. So the mountaintop removal coal mines are shown in red here. This is in Appalachia, generally places that are fairly economically depressed. And when you look at deaths from respiratory disease, it really concentrates pretty highly around these mountaintop removal sites. So all of this explosion, blowing up the rock and things up above the coal, of course, creates massive amounts of dust, and that leads to respiratory disease problems. Similarly, looking at deaths from cancer, again, there's a correlation where counties that have higher rates are typically counties where there is mountaintop removal coal going on. So there's a real human health impact to our coal extraction habits. Now, if you look at what's happened over the first part of this 21st century, the amount of coal being extracted was in fact going down, right? It's since about 2008, coal mining has been going down, whereas production of natural gas has been increasing. And that's due to a couple reasons, one of which is that it's been just kind of easier to get to natural gas, and it's expensive to extract coal. So with natural gas, hydraulic fracturing is this technique that has allowed us to extract more natural gas than we could before. And so shale gas is that fraction. And so if we look at the amount of gas that was produced from 1990, these were data that just went up through about, I think, 2012. The report was released in 2013. I'm sorry, 2011, the date went through. This is really going to be massive. There's a lot of natural gas that's being produced, and it's a good thing from a climate change perspective, and that it has less of a climate change impact. But it's still a fossil fuel and still problematic from that perspective. The way hydraulic fracturing works is that you drill way down underground to the rock formation that is keeping methane, and so methane is a natural gas, right? Then when you get down to the gas-bearing formation, it turns to the side and drills. And then you inject a fluid down under pressure, which causes the rocks to fracture, hence the name fracking. And then when they fracture, those cracks in the rock allow the natural gas to flow back into that liquid, and then it can be extracted and taken back up to the surface. Okay, so a little bit about petroleum. So oil has been the world's most used fuel since the 1960s, right? And especially when we saw development of suburbs post-World War II, petroleum was what people used to drive their cars around. It still is, obviously. And today, the U.S. consumes about 25% of the world's oil. Now, you may be familiar with the environmental impacts of extracting oil. There are these oil spills that happen occasionally. The Deepwater Horizon several years ago spilled about 3 million barrels into the Gulf of Mexico, and there was a massive cleanup operation all along the coast. A massive environmental disaster, and you can just see here how much of an area was affected by the Deepwater Horizon. And of course, this oil all drifted to land and was just a massive, massive problem for the marine environment. But what maybe you don't know is that in the U.S., we consume about 4 times the amount of oil that was spilled by the Deepwater Horizon every day, right? So as much oil as was spilled, that's just the tip of the iceberg when it comes to the amount of oil which the U.S. consumes every day. So we can ask the question as well, how long will the petroleum last, just like we did for the coal? And so most estimates predict that oil production is going to peak sometime in the middle of this century. But the thing you got to keep in mind is that there's this imbalance between the oil producers and the oil consumers. They're not the same countries, as we've seen now, right? Where Saudi Arabia has massively increased the amount of oil. They've flooded the market, and so the cost for gasoline has gotten so low, right? So not all countries are going to be affected at the same time. But peak oil production is likely going to occur in the middle of the century, and from then on, the amount of oil produced globally is going to go down and continue to go down. So the reason that we know that we can estimate this is because the prediction of oil production in the lower 48 United States was pretty accurate, and so it was predicted to peak in the 60s. In fact, it peaked in about 1970. And since then, the U.S. has been producing less and less oil. And so you can see actually U.S. oil production has followed along pretty closely. And the lower 48 have been producing less and less oil since the 1970s. So global oil production, again, in this estimate, well, this estimate actually has a little bit earlier peak. This has 2020, but conventional oil, in other words, oil that is extracted not from offshore oil or polar oil or deep water, that actually peaked in 2005. And so you can see the amount produced by Russia was a big part of that. And again, if you look at the lower 48 U.S. states, that kind of brown polygon there, you can see that peaked around 1970 and has been decreasing ever since. So this is what's projected, right? And then toward the end of this century, the amount of oil is going to go down and down. So here's the problem, as I was mentioning. When you look at the consumption versus production, right? The United States, we have to import 60% of our oil, which means that other nations control our energy supplies, right? We do not have control over our energy. We're at the mercy of whatever people are going to sell it to us for. Germany and Japan are in similar situations. Places like Saudi Arabia and Iran, of course, produce more than they consume. So it's problematic, right? And it can put us in a bind in the foreign relations sphere. So it's important to gain energy independence and not be dependent on all these foreign countries for our oil. So switching from fossil fuels to renewable energy is not it's not a question of if, it's a question of when, because we know that coal is declining, we know that oil is declining. How are we going to get our energy? And I'll just show you an example. So again, what we know is that when resources become more and more scarce, they become more expensive. So this is a projection of demand for fuel, for crude oil compared to production. So demand is expected to go up and up throughout this century. Production, on the other hand, is going to go down. And so conventional oil will be dropping. Bitumen is also known as tar sands oil. So it's oil that is extracted from sand. And it's a very expensive way to get oil, but it becomes more economical when the price goes up. It's also very environmentally degrading, as we'll see in just a moment. So this is the problem, right? As this disconnect between demand and supply happens, the price for oil is going to go up and up. So let's just take a quick look at the environmental impacts of extracting oil from these tar sands. This is along the Athabasca River in Alberta. So extracting crude oil in this way takes twice as much energy as surface mining. So this huge piece of equipment that are involved here. So to produce 1 barrel of crude oil, you have to, of course, cut down all the trees in that area, remove 2 tons of peat and soil, remove 2 tons of sand. Then you have to heat several barrels of water to boiling to separate the oil from the sand. And the water is then dumped into settling ponds, all that wastewater, which is a combination of water and oil. And right now there's about 50 square miles of these wastewater ponds up on the Athabasca River, which is up in Canada. It's in Alberta, Canada. And the picture here shows one of these settling ponds, and it has a machine here. It's a radar-activated mechanical bird. And you might ask why there's a mechanical bird there. Well, it's supposed to look like a hawk, so that when it senses some birds coming in, that hawk makes a hawk-like call and flaps its wings. And the idea is to keep birds from landing in these ponds, because there were about 500 migratory birds that landed in one of these several years ago and were killed. So it's an environmental catastrophe from a lot of different perspectives. So these oil sand fields in Alberta on the Athabasca River, which is shown there on the upper left, this wilderness, absolutely beautiful place. They hold a lot of oil, about 173 billion barrels based on one estimate that I saw. So the question is, how much of it are we willing to extract? So the image on the lower right there shows what this place looks like after it's had the tar sands extracted. So we're turning the ecosystem on the upper left into this environmental catastrophe on the lower right. Now, that sounds like a lot of oil, 173 billion barrels, but it turns out that is just enough oil to last our country about 20 years. 20 years, right? Which sounds like a long time. But you know what? When that 20 years is up, we're at the same place that we were before, and we've lost the Athabasca River ecosystem. So the question then for us and energy is not, are we going to switch to renewables, because we're going to have to. The question is, when are we going to do it? Are we going to wait until we've squeezed every last drop of fossil fuels out of the planet with some pretty massive climate change and environmental impacts? Or are we going to start switching over a little bit earlier to spare the environment, to help with climate change, and, frankly, to make us independent of a lot of these other countries who are controlling our energy supplies? So that's the question. And then in our next lecture, we're going to talk about renewable energy. Thanks.